Where is it? Hello, everybody. My name is Bigpod, and today we're going to talk about demystifying Kubernetes pods. Let's begin, shall we? uh, let's just move the camera a bit so I look better. Not my forehead chopped off. Okay, this looks better. Okay, here we go. So today we're going to talk about Kubernetes pods, how Kubernetes pods work. So first of all, I am looking at the poll I posted, and apparently nobody knows Kubernetes. So let's first talk about what Kubernetes pods are. So Kubernetes pods are essentially groups of containers running on the same node, and they share certain resources between them. So yeah, that's what Kubernetes pods are. Essentially, it's a bit more than just that, but that's the easiest way to do it. It's basically multiple containers on the same node that share certain resources like networking and stuff like that. And let's try and see how they share it, and then maybe try recreating one ourselves. What do you say? Also, let's wait up for a couple people more to join. Uh, yeah. How is everybody doing? In the chat, please tell me how you're doing, and if you have any questions, please let me know. And Joshua asks, how was NixOS? Well, NixOS is pretty nice, but I'm not exactly the biggest fan of it. Personally, I think it does things a bit weird and all that. Hello, George. Welcome, and yeah, you can listen, and maybe you'll learn something. I hope. That's the goal of it all, for people actually learn something. And I also learned something. So, okay, all the publishing is done on all the relevant social media. So now we can try to begin. So as we talked about what Kubernetes pod is, and let me just reiterate, it's essentially a group of containers running on the same node, sharing certain resources. So we need to figure out how they share those resources. That's the important part. And then let's try to recreate it with containerd. So let's see. A big help in preparing for this stream was a blog post by Ximius, who did a deeper look in difference between containers and pods. So I'm gonna be in big part. I'm gonna be using his blog post as a basis of what I'm talking about. But let's begin. I have a VM with uh and hello Hibdad. I have a simple VM setup with as you can see, main content, this one would be. As you can see, it's again terminal. I messaged into one of my VMs which has Kubernetes setup. So if we do kubectl, we have Kubernetes cluster. It's a single node K3s based cluster, and I see more of you actually know Kubernetes. 29% of the 7 votes. Okay, so a couple of you actually know Kubernetes. That's nice. Andrea, the difference between Kubernetes and Docker is a runtime of containers. So a single node runs containers, while Kubernetes is a orchestrator. So it deals with all the stuff like on which node the container will run, and all that stuff, while Docker only cares about one node. Docker also has a mode called Swarm, which essentially then works kind of like Kubernetes, just not that great. So we see we have a simple Docker Kubernetes install. It's actually K3s single node cluster, and we have no pods created yet. Let's see. kubectl get all. We see we have only a single service, Kubernetes, which is a standard service you can create. Now let's create a 2 container pods. So we're gonna be, we still have some tools from last time, but which we're gonna actually use. No, you can't sudo apt install Kubernetes, Joshua. You need to use actual like scripts and stuff like that. For example, for K3, there is a script to use it, but it's actually a lot of components, not just one single component, because it's really pluggable. And I have in past likened Kubernetes to a data center in software, which is pretty close description of Kubernetes, because you can really replace almost every component of it with different style of component that works. Like because a lot of it is based on specs like CNI. CNI is a container networking spec. We actually checked it out last week, where we were doing the overlay networking, where we used containerd and nerdctl. We in conjunction with CNI to create our own overlay network and applied it to our containers, between which were running on 2 different machines. If you wanna check that live stream out, you can check it at the link I will post in the chat in a minute. I just need to find it on YouTube because it's me, and I tend to remember these things at the last moment. So link is in the chat for that stream if you want to learn later on. And thank you for the likes, and if anyone wants to subscribe, of course subscribe. You're gonna be made aware of when I stream next, especially if you click that bell icon beside the subscribe button. That's the YouTuber thing we need to do. So now to continue about our talk of Kubernetes pods. So we're gonna be building one pod. So let's create a file we're gonna need. So I use Nano instead of Vim or Emacs. I use for when I'm working in in a terminal. I use Nano. So what we need is actually a single file. We're gonna name it pod.yaml. It's a YAML file. So a basic skeleton of a file. I'll just copy from Kubernetes documentation, because they have amazing documentation. They're really in detail and really nice. So I'm lazy like that. Well, it's not that Vim is too complicated for me. It's the fact that I don't want to use Vim. Honestly, I don't want to use Vim because for most stuff, when I actually am using stuff and I'm anywhere near going into coding, I'm probably gonna use VS Code. If I'm doing quick edits, like this will be a quick edit, really. I'm gonna use Nano because it really doesn't matter which editor you use, since I will not need any IDE features. So what's the point of learning Vim? Vim is only useful when if you wanna learn to do big things like all the what it called, all the IDE features it has. And I see more and more people actually know how to use Kubernetes in my chat. Nice. Thank you everybody for joining. And don't forget to click the like button if you like the stream. Yeah, PyCharm is pretty nice for a Python editor. I agree. I've been checking out Andrew, I've been checking out Rider, which is C# editor by same folks that make PyCharm. So JetBrains do really good IDE tools. I use their what's it called, their IntelliJ IDEA when I was learning Java, which wasn't fun, but at least I didn't have to use Eclipse. So we're gonna make another container here. We're gonna make an Arch container because I know that has curl inside. And one space too little. We're gonna name it Arch. We're gonna do an image of Arch Linux latest, and no port. So this is all okay. Now we have two. Now we're gonna have two pods, no, two containers inside a single pod. And if we use multiple servers, multiple nodes for a Kubernetes cluster, so in this case we only have kubectl get nodes. We only have a single node called stream, which is a control plane and main server. It's a 1.25.6 version of Kubernetes, and it's ready, which means it's active and ready to deploy code, ready to deploy containers. So now if we go sudo kubectl apply -f our where is our pod.yaml, and now it deployed our deployment, which is essentially an object inside Kubernetes API that, or Kubernetes management service, which which has multiple with multiple containers as a pod, and manages other stuff than just the pod. So it's a bit more complex of uh, an object than just a pod. You could just create a pod, but deployment also creates some other stuff that make management of a pod a lot easier. If we actually look at our default namespace, we see 3 pods for some reason. All 3 are crashing. Let's see what we made wrong. Okay, so we made 3 replicas. Good job, me. And probably an old version. So we're gonna do a latest, not latest. That was a letter in Slovenian language. So I'm gonna apply the pod. So now what the deployment, what the Kubernetes API does, it just changes the deployment. It doesn't actually delete anything, just changes the deployment. And then the kubelet, which is the program behind which then works with your runtime container, right? In this case, I'm using container D. Applies those changes. Basically, Kubernetes tries to get to the same conditions you set in the configuration. So tries to get as close to as possible to the conditions you set in the your YAML file which is just applied. So if we look at it now, we should probably see not ready. What is not ready? Let's see. Sudo kubectl get describe this pod. And which container isn't working? Arch Linux is in waiting state. Is it crashing, terminating? It doesn't work like that. This is a container, so it's not a package. It's a container. So containers are on example Docker Hub. So it's if you know Docker, you know how Docker containers work. This is essentially adding Docker containers. So standard thing is you add a Docker, you build a container of, let's say, I don't know, of your thing, and then you apply that container, you put that container name in that. Yeah, you could add a container of Python 3.11, of course, but you would still need application in it. So what you normally do, you create a Docker file, something like, let's create a Docker file really quick. Or in Podman's case, that would be container file. And let's just simply go from Arch Linux latest, and we can add stuff, we can delete stuff in this format. What I'm gonna do, I'm gonna change the entry point to be sleep infinity. So it actually sleeps, doesn't actually end. So infinity. So I could run commands like, for example, run pacman -syyU. This would update the system. And if we then run docker build, oh, I don't have Docker installed, of course. Yeah, I can't do that right now. But if you run docker build dot, you would this container will be built, and you can apply it. Of course, I will need to push it somewhere to a registry to use it. Sorry. But normally you just run containers. You can look up at on Docker Hub how many containers are there. I'm just using 2 specific containers for example showcase. But normally you would want to create your own container. You know, of Nginx, you would use Nginx latest as a basis, then actually create container that either contains the code or whatever you need to do, or contains the website. So what we want here is an actual entry point here, but I can't remember how to do an entry point on Kubernetes. Set entry point. Here we go. Okay, all I need to do is command colon. We go sleep, and then we do args infinity. This should sleep it for infinity, which then means it shouldn't crash. Now we just reapply the file. Okay, I forgot to do the -f flag. Now if we look at all the stuff in the default namespace, it's running. And it's running all three trees. So for some reason, let's just delete this deployment and delete. As you see, there soon will be nothing there. Right now still is, because it's cleaning up. Oh, I see, I forgot to save the change for just one replica. Okay, it's still terminating those pods. I just wait for those pods to actually terminate. Okay, it's still terminating those pods. Okay, now all pods are terminated. Good. Now we can again apply. If you have any other questions in chat, please let me know. Would love to answer them. Now that should have applied, and we see we have two have a running pod, which means all the containers inside the pod are running. Now let's try and get into that pod. So sudo kubectl. Let's see exactly. Okay, exec dash help. Okay. Now we're gonna need to do a describe of our pod because apparently I forgot how I named it. How I named the container we want. We want the arch container. So exec dash c this, and then we need just a pod name real quick, like this. Okay, the other way around needs to be. And we need to dash bash as well, so I can actually execute the container. What? Okay, yeah. I need to make it an interactive TTY. Alright, a second. So now we're in actual Arch Linux container. If we actually look into slash etc cat os release, we see it's Arch Linux rolling. This is, I don't know which build, when it was built, let's say, but it's a rolling release from pretty lately. Now, we know we have an Nginx running in the same pod, so, and we haven't exposed any ports. So to expose ports, you need to create a service, like you see this Kubernetes service. This would expose a cluster IP. Cluster IP is actually one of those overlay networks we talked about last week. It works on its own overlay network, but we didn't do a service. We didn't do a cluster IP, so we couldn't access Nginx, right? Not exactly. Curl http //localhost 80, and if pods work as I know they work, they should have a return, and it does. The reason why is because they actually share networking. So port 80 is actually port 80 of both containers. This container, the second container that I created of Arch, cannot now have port 80 because of it. Because another container in the pod has port 80. So what we're gonna do is we're going to open up container D, now that we have seen it work and that we have a local host. We're gonna have and see what container D says. So ctr namespaces and list. We're gonna see that we have a default namespace. What namespace is that? Default should be default. Oh, no. I forgot something. K3s has its own container D. So we should do sudo K3s container D, right? Or CTR. Right, yeah. NS and ls. And we get k8s.io. This is the one we want. So ns ls. So then we do ps-n k8s.io and pso. No help topic for ps-h. Oh, it's not ps, it's c.p, cps, cps, right? The ls. Okay, good job me. Dash and k8s.io. H, okay, ctr dash help. Okay, oh, I see what we need to do. I need to do dash n k8s.io here. So we see a bunch of images, a bunch of containers actually. So this isn't what we're looking for. This isn't what we're looking for. What we're looking for is this. This is our container that we created, and this is our container that we created. I'm looking for another container. There might be another container that we created. But what we want to now do is look at what Ximius created. There is a command I need to learn. Okay. So first we're gonna look at actually a simple Docker container container as well. So sudo nerdctl run nginx. It's running, it's working, so I'm gonna just do the same with -d, so we have a -d. So now all we need to do is get ourselves an ID. So we actually have ID, and then we need to do ps oxf. And what we want to know is that container. So we're gonna do the we're gonna grep for this, and we have it. That's it. That's the thing. That's the thing we're looking for. So that should be PID. That should be PID. This one is the PID. Yes, that should be PID. This PID. This is the PID that we're interested in. This is the container D container. Now we're gonna do sudo lsns. We got a lot of things. We're gonna this and this. Grep. Huh. That's strange. That's strange. Huh. Wait, what? That ain't correct. Oh. I might have the wrong one. Of course. Am I genius? I'm gonna need to do it a bit more manual. What we want is actually this one. So 1272. 12072. Okay, great. Now we can talk about the namespaces. Now namespaces is actually a kernel feature. So Linux namespaces. So they're a feature of Linux kernel that basically partition kernel resources so that one process only sees its own resources and another process doesn't see that process resources. For example, we're talking about 6 different, or 5, 2, 3, 4, 5, 6. Please tell me I count correctly. 2, 3, 4, 5, 6. Yes, 6 different namespaces. Our container D runtime is sharing. So first is the mount container, so mount namespace. So that this means that it has isolated mount table, so its own root fs and all that. Then we have UTS, which is Unix time sharing, and that just is a container, that is namespace that allows to have its own host name and all that. Then we have IPC, which is interprocess communication, which means that these processes inside a container can communicate via system level IPC calls, but only to the process inside the same container. Then we have PID, so that means that only processes inside the container can see the processes in that container. they can see into process to another container. And then we have net. Net is basically networking stack. It's all each container has its own networking stack when it has its own namespace. There are other namespaces like cgroup namespace, which isn't the same as cgroup mechanism. As you can see here, this is a cgroup namespace. I don't know exactly how cgroup namespace, what exactly cgroup namespace does, but I think all it does, it gives it a separate cgroup hierarchy or something like that. I'm not exactly knowledgeable on that, as that is, I believe Docker doesn't actually do it, or didn't do that in past. Sorry for a moment. I have to take care of something, so be right back. In the meantime, if you have any questions, please let me know in the chat. And thank you for watching my stream. Oh, crap. Okay. Uh, I guess I haven't answered your OpenShift question. OpenShift is just really Red Hat's take on Kubernetes. So whether it's good or bad is really a question of the person who asks, who uses either. I personally like Kubernetes more than Red Hat's take on. on Kubernetes. If there are any background sound bleeding through, please let me know. So now let's look at our pods, how they have this manages. I have actually talked about this previously, but I can read it. Pods are essentially groups of containers that share certain resources. As we will see, essentially they share certain namespaces, while on the other hand, container is a single unit that has, well, certain namespaces applied to it, while pod is a group of containers that share certain resources, and it's really first was seen in Kubernetes. So now we have our two we can look at. Let's find our Nginx in Kubernetes. So we're gonna again look at this. We're gonna find this one. So 9b2f d4, and if we, that would be let's see. I can't find it. Let's grep for this. Nope. That's the range. It should be here somewhere. Oh, I see why. This might be it. Yep, this is it. It's so wide that I cannot see the actual ID. So I think this one is it. That would be my guess. So we have this bit to grep for, and we see it only has three namespaces. Wow. Mount, pid, and cgroup. Why is that? Well, I don't know. Should have more. But there is actually a better way to look at a single pod. So we're gonna look at let's see. We're actually gonna look at the namespace, actually. So this is the namespace we wanna look at, or no? Now I'm actually questioning myself. So we're actually going sudo ls-l/proc, and this will be our 11045/ns, and we're gonna get all the namespaces. And now we're gonna also look at another one. So now that we have that, we're gonna just check out one of the namespaces and see. So we're gonna look at network namespace for a reason. LSNS, and we're gonna do this, and we're gonna see it also is applied to POS container. Now, it only writes for POS. The reason is that LSNS apparently only writes a single namespace once. So what we want to do is actually check out this this more manually with lsproc. So what we want is, so this is our container for, this is our nginx container. Now we also have this net container, or not container, this slash pods, which has this. So I'm going to lsns for this, and we get PID of 11012. If we go and PS, and we're just gonna grab for this speed, we're gonna see this is the pause. Now we're actually talking about this one. As you can see, it's actually inside the same major process of this, which means that is why they share certain stuff. We ask PS AUXF, this is what the top process is. So this is what it init is essentially, I think. Now we want to look at this one, Sleep Infinity, the 11102. I don't know yet what's for dinner. Very strange question. So our Sleep Infinity, this is our Arch container. This, let's just lsns this. We're gonna see it also just has mount PID and C group, MNT PID and C group. Everything else it shares with this pause container, with this pause, which, as we established, is 11012 and should be somewhere here. So what that would suggest is that each of these three containers is a part of one larger process. But if we look at our process, which we're talking about, is 11012. Actually, let's look at all three. Sudo ls/proc, this one /ns. We see each one has its own set of this. And then if we compare, if we do the second one, which is process 11045, this, and third one, which is 11102, we see that we will see that some of the C groups, some of the namespaces actually are shared, and some of them are separate. So as we can see, IPC is 402653, ends with 57, ends with 57 here, and ends with 57 here, which means that the inside the pod, all namespaces, all containers inside the pod share network namespace, they share IPC namespace, and they share UTS namespace. So they have single host name, actually, technically speaking. And so which means you can these containers can talk to each other using shared memory, message queues, etc., and with localhost, which is kind of great if you want to do stuff like sidecar containers, stuff like that. Now, how about we create this on our own, right? Let's see if I can do that. Let's see. I'm not so sure I can actually at the moment. CTR. nerdctl run-h. This is the part where I don't know anything and we need to figure it out. So while I think I could do it, it appears my time is up. So thank you everybody for watching. Don't forget to like, subscribe, and comment. And don't forget, I'm bigpod. Join next time, next week, where I'll be doing something with containers. Apparently time flies when I'm streaming, so happens. Sorry, I wanted to create one and I think I could, but well, that happens. See you next time. We could do that next time. Yes, Joshua, we could make something like that. That shouldn't be too hard with Kubernetes or container that implements pods. See you next time.